So I will be discussing the Innovative Designer Standard from Iste, which is standard number 4. So this standard, according to Iste, encourages learners to take risk. It also allows students to really be creative and learn new skills. There are multiple solutions to problems, and that's important because it also allows students to see multiple viewpoints and understand that there's not one solution for every problem, which then also encourages perseverance. There will be failure, and they have to learn how to work past that. So as someone in educational technology, this is an important standard because knowing about this standard will allow us to properly evaluate tools. We don't want to use technology for technology's sake. So having the ability to discern which tool is best for which project, what is the learning goal? So what tool would best suit that learning goal? And then also be a model and a resource for teachers and students. There are so many tools out there that knowing about the standard and the tools that we can use to meet this standard can help us be a resource for teachers and students. So there are 4 substandards within the Innovative Designer Standards. The first one is students knowing and using deliberate design process for generating ideas, testing theories, creating innovative artifacts, or solving authentic problems. So this reminded me of a project we do in our 6th grade with Tinkercad. So students are given the real world issue of designing a school supply that they feel they might need. So they design it on Tinkercad and then they 3D print it, and then they're allowed to use it throughout the day. That is an authentic problem because it's something that they do in their everyday life. Standard B, 4B, is students selecting and using digital tools to plan and manage a design process that considers design constraints and calculated risks. So our 7th grade does a passive housing project where they research the idea of passive housing and the elements of a passive house, and then they use Tinkercad to design it, working collaboratively. And they also use Trello, which is a collaborative project management tool, to keep track of the steps in the engineering design process that they use. And any notes they need as they go along are posted here. And then at the end, they use iMovie to create a video of how they went through the process of creating their passive house and the notes and the redesign steps that they needed to take. Standard 4C is students develop, test, and refine prototypes as part of a cyclical design process. So 8th grade students are given the real life problem of developing a hydraulic arm that can be used during a medical surgery on eyes. And they use Google Docs to collaborate on research and notes throughout the engineering design process. And then they use Google Slides to then present to the class how they went through the steps, their research, their redesign, their planning, and they present that to the class. The last standard is students exhibit a tolerance for ambiguity, perseverance, and the capacity to work with open-ended problems. And in our 8th grade, students take a mobile app course using MIT App Inventor and Kindle Fires. So they are given pretty much carte blanche to develop an app of their choice. And throughout that, because they've never done it before, they're constantly testing on the Kindle Fires. And there's always something initially that goes wrong, right? Because they've not used this app inventor before. And so they have to work out those problems of the app and eventually get it to work. And our teacher gives them a bunch of tutorials on our learning management system. So they have the capacity to advocate for themselves if they need help and work out the problems on their own.